Hey there, Mr. Weaver here, and this is lesson 4 of topic 4a. And in this lesson, we're going to solve our systems of equations using elimination. After this lesson, you need to be able to solve systems of linear equations with two variables by using the elimination method. And you need to be able to explain how and why you use the multiplication property and addition property of equality when we're solving with elimination. You'll know you're successful after this lesson if you can solve your system of equations using the elimination method, and if you can explain how you use the multiplication property and addition properties of equality to solve using elimination. So this is our second method of solving our systems of equations. So remember, our whole goal for this is to figure out what value of x and what value of y is true in both equations. So elimination is just a different way to solve it. With elimination, the first thing you're going to do is line up like variables in the equations. So you're going to put the x, the y, and the constant in the same order. Generally, they're going to look like standard form, where it's something x, something y, and then equals a number. Once they're like this, you're going to add the equations as if it was like an addition problem that you learned in first or second grade. This will eliminate the variable that has opposite coefficients, and then you can solve for the variable that remains. If neither variable has opposite coefficients, and we'll look at what this means in a minute, then we can multiply one or both equations by any constant to create opposite terms. Once we figured out the value of that first variable, then the steps are just like we did before. You're going to substitute it back into one of the original equations, solve for the other, and then you're double checking your answer by also doing the same in the other equation. And then again, you would write your answer as a coordinate point. And then this method is best to use if both lines are given in standard form, where it's ax plus by equals c. And you'll see all of our examples, they're going to look like that. When we're using elimination, rephrasing what kind of the steps said, you need to get the coefficients of x or y to be opposites of each other. So here's an example. If we look, we can see that the coefficients of x, so 3 in the first equation and -3 in the second equation, those are opposites of each other. That's what we want to get. Or in this one, we have -5y and +5y. So we could either have the x's be opposites or the y's be opposites. As long as one of them is, we're good. The reason we need this is because we are going to add them together. And when we do that, if they are opposites, they make 0. They are additive inverses. And if there's 0 of it, then it goes away. So by adding opposites, we're able to eliminate one of the variables. And so in this first one, we could just solve for y and get y would be equal to -1. Or if we did the same in the second one, we would end up with 6x equals -9, and we could solve for x this time. If things are close but not opposites, so here we have +2 and +2, then, as the step said, if nothing is going to cancel out, then what we can do is multiply one or both of the equations by something so that we're able to cancel it out. So if I multiplied that top equation by -1, I would end up with +4x minus 2y equals -2. Now those are opposites. I could cancel it out. I could do the same thing. I could have chose the bottom one to multiply by -1, and then this time the bottom would be negative. They would still cancel out. It doesn't matter which, as long as you're multiplying everything by that constant, You'll still get the same answer with whatever equation you choose. Let's go through a few examples. So in this first one, we have negative 2x plus 3y equals negative 4, and positive 2x plus 6y equals 13. I have negative 2x and positive 2x. That's what I'm looking for. Then I'm going to add them together. This is where the addition property comes in. If I can visualize the second equation, 2x plus y equals 13. Well, they are equal, which means they have the same amount on both sides. We just don't know exactly how the 13 is made up on the left. But when we add it, we are actually just adding the same thing to both sides, which is where our addition property comes. So adding, I would get 9y equals 9, divide by 9, and y must be equal to 1. Now we can choose which equation. So if I plug in y as 1 into the first equation, now I can simplify it to solve for x. So 3 times 1 is 3. Then to get x by itself, I would subtract 3 from both sides and divide by negative 2. So x must be equal to 3.5. We're going to check in the second equation. So if I plugged in 1 for y, I would get 2x plus 6 equals 13, 2x equals 7, so x equals 3.5. I got the same answer both times. Again, that's helping confirm that I did it correctly. 3.51 is my answer. Remember to put it in the order x, y. Now it's your turn. Pause the video and see if you can figure out how to use elimination in this problem. Things aren't going to exactly cancel out, so you might need to multiply either the top or the bottom by some number, so that way you can use elimination. See if you can figure it out. Check your answer. You should have got 4, 2. Let's look at how we got that. If we look closely, we have positive 4x and positive 4x, which means if we multiply one of them by negative 1, so either the top or the bottom, we'll be able to cancel things out. So I'm going to say that we multiplied the bottom one by negative 1. When we do that, going through and solving, we would end up with y to be equal to 2. Once we plug in 2 back in, solve for x, we end up with x equals 4, and our solution would be then 4, 2. Don't forget, you can also use Desmos to help check and make sure you are doing things correctly. Let's look at another example. So we're still going to use elimination. So 6x minus y equals negative 7, and 3x minus 8y equals 4. If I look at my coefficients of x and my coefficients of y, neither of them are exact opposites of each other. So I have 3 and 6, or negative 1 and negative 8. What I can do then, like we did before, multiplying by negative 1 to make it opposites, we can also choose different numbers. So if I chose to multiply the bottom one by negative 2, then I would end up with that negative 6x where I could use elimination. So doing this, the top one is going to stay the same. I didn't multiply it by anything. But the bottom one, multiplied out, everything would get multiplied by negative 2. So negative 2 times 3 would be negative 6, and that was with the x. Negative 2 times negative 8 is positive 16 with y. And negative 2 times 4 is negative 8. Now I can use these equations for my elimination. So I'm going to add them together. 15y equals negative 15. So y is equal to negative 1. Plug that in like we did before. Carefully work it out. I end up with x equals negative 4/3 or negative 1.3 repeating. If I check the other one, plug in negative 1, simplify it out, I also get x equals negative 1.3 repeating. Same answer both times. So negative 1.3 repeating, or negative 4/3, and y would be negative 1. Before you try your example, please change it to the one that I gave you here. It works better for elimination than the one that's in your book. Once you've fixed it, pause the video and solve by elimination. Let's check. So this one, you didn't have to, but it would actually be easier to eliminate y because one's already positive and one's negative. If you had multiplied the top one by 2, then the y's would cancel. So the top one would change, the bottom would stay the same, cancel out. Either way, no matter how you did it, you should have got x to be equal to 5. You could have also multiplied the bottom one. Maybe you saw that the first number was a 1. You could have multiplied by -4. However you did it, one thing is the opposite coefficient of the other. Once you get 5, you plug it into both equations. I'm not going to show it here for sake of time, but you should have got 2 for y, so your coordinate would be 5, 2. If you want to know if you multiplied your equations correctly when you're making new equations, you can also use Desmos. So in addition to finding out what the answer would be, you can also use Desmos to check to see if you multiplied correctly. So here's the problem that we just did. If we chose to multiply one equation, so say the top equation by 2, and we got 8x minus 6y equals 28. If you type in your newly multiplied equation correctly, it will show up in the exact same place as your original line. So notice my original line there was black. I graphed my new one, it turned blue. It's in the exact same spot. I did it correctly. Had I multiplied the bottom one by, say, -4 to cancel out the x's, then it shows up in the same place. Okay, if something's wrong, so let's say you accidentally forgot to multiply something, it is no longer in the same place. That's a good way to check and be like, oh yeah, I did something wrong. Okay, so if they're correct, they show up in the same place as it was before. Let's look at one more example. Here, the x's are not opposites. The y's are not opposites. There's nothing really I can easily multiply 3 by to get to 2, or 5 by to get to 3. Or if I go from the bottom, multiply 2 to get to 3, or 3 to get to 5. So what I'm going to do is multiply both equations. So if I chose to multiply the top one by 2, and the bottom one by -3, or I could have done -2 and +3, or a bunch of other combinations. When I come up with my new equations, I now have opposite coefficients. My x's will eliminate, and I will be able to get y equals 4. In fact, if we did it this way, I didn't have to solve anything. 10 minus 9 is 1. There's my 1y already. 52 minus 48 is 4, so y is 4. Now to figure out the rest, I'm going to substitute in like we've been doing. X is equal to 2. Let's check in with the other equation. Substitute 4. X is also equal to 2, which means our final answer is 2, 4. Pause the video one last time and solve this one using elimination. Multiply one or both equations if you need to. Let's check through this. Personally, I noticed that y had a negative coefficient and a positive coefficient already. So if you had chose to eliminate y, then you could have just multiplied the top by 4 and the bottom by 3 and got your new equations. But again, that's not the only way. You could have multiplied the top by 7 or -7 and the bottom by 4 or -4 and eliminated your x's. Again, it doesn't matter how you're doing it. Choose something that works. So you should have figured out that x was equal to 1, substituting it back in, y was equal to -1. So your final coordinate should have been 1, -1. In this lesson, we learned that elimination involves your addition property to cancel out one of the variables because you're adding the same things to both sides. If nothing cancels right away, then we're using our multiplication property to multiply both sides of one or both equations and creating an equivalent equation where they will now cancel. Then we can add the things together and solve just like we've been doing. After this lesson, do you now know how to solve a system by elimination? Can you explain how and where the addition property of equality is used? And can you explain how and when the multiplication property is needed when we're using elimination? If you're not sure about these things, go back and look at some of the examples, what our goal is, and see if you can figure out some additional ways that you can remember how to do elimination. And that's the end of lesson 4 on solving systems of equations with elimination.